Hello everyone, good evening. I hope you all are good and doing well. How is everybody? कैसे हो सभी लोग? How is everyone? Fine? Great. Are you people doing questions from the chapter Electrostat? You went through your NCERT questions? How many of you tried at least? If yes, you can let me know. ठीक है? Okay, okay. Thank you. Very good. देखो एक चीज मैं बोल दूं प्लीज स्टार्ट टेकिंग थिंग्स सीरियसली प्लीज स्टार्ट डूइंग क्वेश्चंस आई एम आल्सो गुड या आई एम फाइन I just want to tell each one of you here we are about to end the two chapters I would say from NCERT textbook and still if you have not started doing questions it's really something disappointing I would say because in physics if you're not practicing question if you're not doing it I mean it's class is not going to help you because after some time class will become just a history it will become a past if you don't want this concept these classes to become simply a part of your past I mean you want it to be there in your present you need to practice question otherwise what will happen nothing you will just remember okay we studied electrostat this thing we studied these chapters we studied but you're not able to translate it into marks you are not able to translate it into uh, question solving I mean after 6 or 7 months maybe randomly someday you will be sitting for some test let's say AIT test you will be sitting for and then you will realize okay you're not able to solve the question at that point of time maybe you will be thinking ma'am ne kya padhaya tha we are not able to do question but this is not how physics mathematics even physical chemistry things go forward right you have to invest in it you have to do the questions very important part of your study is that you are practicing questions please make sure you are doing it I mean I can just only say this to you I'm not there just sitting in front of you or standing in front of you to I mean guide you in that way I cannot see if you people are doing it or not I mean that's real frustration coming in me as of now if you people are not doing it I mean my effort will again go in vain you won't be able to do anything so please help me. I won't say help yourself. I would say that's more better line, है ना? Because if you're doing questions, you're going to help yourself. That's very much required. Please do it. Please, everybody. ठीक है? चलो. Now we will be starting with today's topic. That is, उससे पहले मैं थोड़ा रिवाइज कर दूं तुम लोगों को. So we studied electric field due to dipole. मैंने जो भी 2-3 मिनट का लेक्चर दिया, please have that in your mind. ठीक है? I mean, मैं गुस्सा नहीं कर रही. I'm just telling you this is very important. That is why I'm stressing on it so much. Done है? So we studied electric field due to dipole. Dipole क्या था? Positive and negative charge, equal positive and negative charge separated by certain finite distance. And that distance is actually very less, right? That is your dipole. Dipole moment का formula क्या था? It is indicated by letter P. Formula is charge into distance between them. And direction is from negative charge to positive charge. This is the dipole ka direction. We calculated electric field because of dipole at a point on the axis for r far greater than a. We got the formula 2 kp by r cube. Here direction of electric field is in the direction of dipole. And we also calculated for equatorial point. At this point, we got electric field opposite to the direction of dipole. And its value was how much? Its value was 2 k, sorry, it's not 2, it's simply kp by r cube. And direction is opposite to the direction of dipole. And that is why here negative sign. Okay? After that, we calculated electric field at any general point P. For that, what technique we used? So I told you, treat this dipole like this. Draw this dipole like this. This dipole will have a component in the direction of r vector, that is P cos theta. And then this P will have a component perpendicular to the direction of dipole, that is P sin theta. And because of P cos theta, you have a you will have a magnetic field at the point P. For P cos theta, P is an axial point. So electric field because of P cos theta, I have written there. कल की क्लास में मैंने बताया था, that will be equal to 2 kp cos theta divided by r cube. And direction here will be in which sense? In this direction, in the direction of dipole. And that of because of P sine theta, electric field because of P sine theta is equal to kp sine theta by r cube. And its direction will be opposite to the direction of dipole, that is. So this is these two electric fields are perpendicular to each other. Net electric field I told you how you will be calculating. So EP cos theta इसकी वजह से जो आया the square plus electric field because of P sin theta का square. That will give you the net electric field. ठीक है? This was the thing. After that, we calculated potential at any point P. There was a general formula, and potential formula was K P dot R by how much it is? K P dot R divided by R ka cube. So if you are going to break it, it will become Kp cos theta by R square. So for axial point, अगर axial point की आप बात करो, for axial point, theta is what? 0 degree. So potential will become what? Kp by R square. And if we talk about equatorial point पे क्या होगा theta? Theta will become 90 degree, है ना? Because this is equatorial and this angle will become 90 degree. Potential will be 0. This is all we studied in the previous class. आज की class में we are going to see how dipole will behave if we are placing it in external electric field. So let's say here, suppose there is electric field like this, ठीक है? Electric field is like this, and what you are doing is you are placing डाइपोल इन दिस एक्सटर्नल इलेक्ट्रिक फील्ड. ठीक है, आपने क्या किया? आपने इसमें डाइपोल को प्लेस कर दिया. ठीक है. नाउ इफ यू आर ड्रॉपिंग डाइपोल, जरूरी नहीं है ये इसी डायरेक्शन में हो. डाइपोल कैसे भी रैंडमली किसी भी डायरेक्शन में हो सकता है इनिशियली व्हेन यू आर ड्रॉपिंग इट. सो what sort of force will act on the dipole? Because dipole means negative and positive charge. If this is kept in electric field will apply force on it. So first we will learn what is the force acting on a dipole placed in an external field. अब देखो यहाँ पे मैंने इलेक्ट्रिक फील्ड लिया है. This electric field, just by looking at it, it is clear that it is uniform electric field. Uniform electric field क्या होता है? बताओ. अगर मैं बोलूं इलेक्ट्रिक फील्ड यूनिफॉर्म है, इसका मतलब क्या हुआ? E का वैल्यू हर जगह क्या है? सेम है. E is constant. And how we draw a uniform electric field? While drawing uniform electric field, we'll make sure that distance between two lines of electric field is constant. अगर मैंने इलेक्ट्रिक फील्ड कुछ ऐसा बनाया, यहाँ पे ऐसे क्राउडेड था, and then I drew it like this, then this is not a case of uniform electric field. This is a case of non-uniform electric field because distance between field lines is not same. ठीक है? So here it is same. It is uniform electric field. E value is constant everywhere. अब देखो, अब जो भी हमने पहले पढ़ा है, we will be using that. This is a positive charge, and you know that on positive charge, force act in the direction of electric field. So here force will act in this direction. Magnitude, charge into electric field, that is the force ka value, right? And on negative charge, force act opposite to the direction of electric field. So in this case, and magnitude will be Q. So total force acting on the dipole, अगर मैं total force की बात करूं, then QE is acting towards right, QE is acting towards left. Total force is what? 0. ठीक है? There is no net force acting on dipole if dipole is placed in uniform electric field. Let's say we are keeping dipole in non-uniform electric field. ठीक है? हमने एक non-uniform electric field लिया, and here what we are doing, we are placing a dipole. Let's say this is plus Q charge and this is minus Q charge. So dipole ka direction is this. Now what will happen? Now we cannot say that the value of electric field at positive charge is same as value of electric field at negative charge. It will be different, right? Because electric field is not uniform. It is changing throughout the space. So force on plus Q charge you will apply as Q E1. Let's say here electric field is E1 and here electric field will be Q E2. Now depending on the values of E1 and E2, one force will be greater than another and hence net force will act on the dipole. ठीक है, क्लियर है सभी को? यस, लक्ष्मी, तेजस्विनी, संजना, रंजू, रजत, दिया, नव्यश्री, कलार्सन, किरण, कार्तिक, सबको क्लियर है? I've taken so many names. Anybody come out, tell me. Okay. Rajat, thank you. Thank you everyone. चलो ठीक है. So हमने पढ़ लिया फोर्स कैसे लगेगा. बी द फील्ड बी यूनिफॉर्म और नॉन यूनिफॉर्म. अब हमें पता है. अब हम चलते हैं दूसरे चीज की तरफ जो कि टॉर्क है. टॉर्क क्या होता है? फोर्स का मोमेंट, दैट इज टॉर्क. सो टॉर्क को हम डिफाइन कैसे करते हैं? आर क्रॉस एफ. डन है. Now we are going to talk about torque acting in uniform electric field. So field को मैंने क्या लिया है? यहाँ पे भी uniform लिया. So if the field is uniform, what I will write here is torque. Let's calculate torque around the center of dipole. ठीक है? So forces acting we already know. This is force QE and this is force QE. Torque कैसे लगाते हैं? R cross F. So किस point के around लगाना है? Around center of dipole. So let's start drawing it. R cross F. This is the first torque. Torque acting because of force acting on the positive charge in this direction. So this torque will be equal to, this distance is how much? This is equal to, let's say, total length of dipole is 2a. Then this is a. तो R का वैल्यू क्या हो गया? A हो गया. And what is the angle between R and F? Let's say this is theta. So angle between R वेक्टर का डायरेक्शन, A वेक्टर का डायरेक्शन किधर है? इधर है. And Q फोर्स का डायरेक्शन towards right. Angle between them is theta. So R cross F. R is what? Distance between the line of action of force. So line of action of force तुम्हारा क्या है? यही है ना, line of action of force. And distance of line of action of force from the point around which you are calculating torque. So that is this O point. यहाँ से यहाँ का distance क्या है? Exact distance अगर देखो तो A है. So यहाँ पे tau 1 का वैल्यू मैं क्या लिखूंगी? A into QE into sin theta. And this is in which direction? Let's see here. This is in clockwise direction. So let's call it tau 1. Also, another torque will act because of force acting on the negative charge. So let's calculate this force R cross F. This torque is also in clockwise direction, है ना? And value will be same as before, A Q E sin theta. So there are two torques, both are acting in clockwise direction. So net torque will be what? Sum of these two. क्योंकि दोनों same direction में है, we can add it now. So add कर लो आप, कितना हो जाएगा? 2A Q E sin theta. And 2A into Q is equal to what? Dipole moment. So this is P sin theta. And P sin theta can be written as P cross E. So no matter electric field is uniform or non-uniform, if you are keeping dipole in an electric field such that angle between dipole moment and electric field is theta, then torque acting on it will be what? P cross E. So this is the formula of torque acting. Done it? किसी को डाउट होगा तो बताना. ठीक है. Now we will talk about potential energy. जैसे हमने पहले पढ़ा था कि if you are bringing charge into a region of electric field, that charge will have certain energy. है ना? जैसे मैंने बताया था, if there is electric field and there are 2 points here, A and B, or let's say there is single point A where you are bringing charge Q. How much work you will done? Q into potential at point A. So this much amount of work that you did in bringing charge at point A will get stored in the form of electrostatic potential energy. Similarly, here this is a dipole having charge minus Q and plus Q. Since it is also a system of charge, though net charge is zero, but still separation between charge is there. है ना, दोनों के बीच का डिस्टेंस है. So both the charges are kept at different points in the electric field and hence different potential, and hence this system will have a stored potential energy in it. And this potential energy formula is equal to minus P dot E. I'm not going to derive it because you don't need it, I would say in short. So formula याद रखना. What will be the value of potential energy stored when a dipole is placed in an external electric field? An angle between dipole and electric field is theta. What will be the value? Minus P dot E. So minus P cos theta. Okay, this is your potential energy. Now there is a very important concept which we need to learn. Equilibrium of dipole. What do you understand by equilibrium? In class 11th you all must have studied. और अगर तुमने फिजिक्स नहीं भी पढ़ा है तो इक्विलिब्रियम का मतलब होता है रेस्ट. ठीक है. सो दिस इज अ पोजीशन ऑफ रेस्ट. और कोई भी चीज रेस्ट में कब होता है? जब उस पे फोर्स जीरो लग रहा हो. When force acting on it is zero, the body will not move or body will not translate. And if torque acting on the body is zero, then body will not rotate. है ना? So if these two things are zero, it means body will be in complete rest, both in rotational equilibrium and also in translational equilibrium. So force and both torque will be zero for this case. Got it? ठीक है. चलो. Now these two things are zero. Let's now understand. Force zero होने का मतलब क्या है? Electric field should be uniform. है ना? अभी अभी हमने देखा force zero कब हो रहा था? When electric field is uniform. If electric field is non-uniform, force will be non-zero. So for translational equilibrium, ये किसका केस हुआ? For translational equilibrium. That is for body to not move, for body to not translate. Electric field should be uniform. For this dipole to not translate, electric field should be uniform. That is, force should be zero. Now, for rotational equilibrium, torque should be equal to zero. और torque का formula हमने अभी अभी पढ़ा है, P sin theta. Now we are keeping dipole in field. So P तो zero नहीं हो सकता because you are dropping dipole in electric field. So dipole is there, also electric field is there, but we have to make torque zero. So we will do something with angle theta. For what value of theta, sin theta will be zero. Theta should be either zero or 180 degree. Because if sin theta is zero, then if sin zero, if you put theta equal to zero, that is sin zero is zero, sin 180 is zero. है ना? sin zero तुम्हारा क्या होता है? Zero. And sin 180 क्या होता है तुम्हारा? Zero. दोनों ही zero होते हैं. ठीक है. So for torque to be zero, theta should be zero or 180 degree. अब theta है क्या? Theta is angle between dipole and electric field. So look at the first diagram. This is first diagram. This is second diagram. In first diagram, electric field is towards right. Is towards right. Dipole is also placed towards right. So angle between electric field and dipole here is what? Theta equal to 0 degree का case है ये. And this thing, this dipole, electric field towards right, dipole towards left. So theta here is 180 degree. ठीक है. So in these two cases, or you can say in both the cases, what is thing? Dipole is in equilibrium. दोनों ही केस में तुम्हारा dipole क्या है? Equilibrium में. क्योंकि दोनों ही केस में torque zero लग रहा है और force तो zero लग रहा है because electric field is what? It is uniform. Done it? Now the thing is, there is two sort of things. Again, equilibrium is of two types: stable equilibrium and unstable equilibrium. ठीक है. Even if body is in rest, even if body is in rest, there are two tendencies. जैसे कभी कभी क्या होता है ना, suppose you are angry for something and someone more powerful than you arrives. Suppose it's your parents and they scold you. ठीक है. And after that you get silent, but you are forcefully silent. You know, you are very angry. You want to, I mean, you just want to spit out your anger. You just want to say whatever is there within you, right? But forcefully, since your parents are there in front of you, they are scolding you and you're not able to speak. So though you are in a state of rest, you are in the state of calmness, but that calmness is not stable, because the moment they will go away, you will, you will express your anger in some way, either by hitting on the wall or doing something, whatever. Maybe you will go somewhere, something like that you will do, right? So that equilibrium, that position of calmness or rest is not stable. Okay. So that is called unstable equilibrium. And suppose kar lo, you are just sitting amid nature everything is so calm. River is flowing by your side, wind is blowing, it's drizzling a bit, and you're just sitting there with your eyes closed. You're completely engrossed by the scenery, and you are actually willingly, you are silent, right? And you want to be more calm, you want to be that stable. There your desire is involved, right? And that sort of state of calmness is called a stable equilibrium, because from that position you don't want to nudge, you don't want to uh, i mean uh, you just don't want to lose that position of calmness, right? So that is called stable equilibrium. ठीक है, pictorially we understood it. Now mathematically, or in the terms of physics, what is the meaning of stable and unstable equilibrium? I took two example. In first example you were angry, ठीक है, पहले एग्जाम्पल में तुम क्या थे, एंग्री थे. सेकेंड एग्जाम्पल में तुम क्या थे, यू वर हैप्पी, है ना? एंड यू वर सोलफुल, वेरी काम, यू वर एक्चुअली काम. Done it? So in first case, when you are angry, angry signifies what? It indicates what? Energy, lots of energy. Okay? So in first state, you were more energetic, violently energetic, right? And in second state, you're like relaxed, no energy there. So less energy, less violent energy, I would say. Okay? So अब एनर्जी के टर्म पे हम आते हैं. एनर्जी का फॉर्मूला अभी अभी मैंने बताया था. व्हाट इज द पोटेंशियल एनर्जी ऑफ डाइपोल केप्ट इन इलेक्ट्रिक फील्ड माइनस पी डॉट ई, है ना? यही था. अब इसको ब्रेक करो, माइनस पीई कॉस थीटा. ठीक है. नाउ कैलकुलेट पोटेंशियल एनर्जी इन द फर्स्ट केस. इन द फर्स्ट केस थीटा इज इक्वल टू व्हाट? 0 डिग्री. हियर थीटा इज 0 डिग्री. पुट हियर थीटा इक्वल टू 0. एनर्जी इज माइनस पीई first case mein. And what will be potential energy in the second case? That will be minus PE cos 180. Cos 180 is how much? Minus 1. So minus minus will become plus, plus PE. Which energy is greater? 1 or 2? Tell me. Which is greater? 1 or 2? Yes. Okay, yes, Lakshmi, very good. Everyone, come on, let me know. कौन सी एनर्जी ज्यादा लग रही है, बताओ. कौन सा टर्म बड़ा है? एक चीज मुझे बताओ, अगर ये -2 है एंड लेट्स से दिस इज +2, विच इज मोर ग्रेटर, -2 और +2?
+2.
+2. सेकेंड वन. यस, थैंक यू. सो +2 इज मोर ग्रेटर, यानी कि PE2 इज ग्रेटर देन PE1. इसका मतलब क्या हुआ? more energetic means unstable equilibrium. So theta is equal to 180 के लिए equilibrium कैसा होगा? Unstable, because here energy is greater. Yes, Rajat. Yes, Kalarsi. Correct. So and theta equal to 0, equilibrium is stable. ठीक है. So we studied about equilibrium. इक्विलिब्रियम के कितने केसेस थे? इक्विलिब्रियम क्या था? ट्रांसलेशनल भी होना चाहिए, रोटेशनल भी होना चाहिए. ट्रांसलेशनल के लिए फोर्स शुड बी 0. फोर्स 0 मींस इलेक्ट्रिक फील्ड शुड बी यूनिफॉर्म. फॉर रोटेशनल इक्विलिब्रियम टॉर्क शुड बी 0, यानी कि थीटा शुड बी आइदर 0 और 180 डिग्री. So for both theta equal to 0 and 180 degree, dipole is in equilibrium. But again, one equilibrium is stable, another is unstable. Which is stable? Theta equal to 0 degree. Because in this case, energy is minimum. Here energy is minimum and here energy is maximum. That is why this is unstable. Done? चलो यहाँ तक तुम समझ गए. नाउ इज द केस ऑफ SHM. SHM अगर तुम लोगों ने 11th क्लास में थोड़ा भी पढ़ा है, नहीं भी पढ़ा है तो कोई दिक्कत नहीं है, बट मैं तुम लोगों को बेसिक कॉन्सेप्ट बता दूं. SHM तब होता है व्हेन यू डिस्टर्ब बॉडी फ्रॉम इट्स स्टेबल इक्विलिब्रियम पोजिशन. ठीक है. whenever a body is in stable equilibrium position and you disturb it, it will have tendency to perform SHM. Suppose कर लो, I am sitting in a jungle, जैसा मैंने केस दिया था, river flowing by side, wind blowing, leaves twirling down. I mean, scene is too beautiful, too good. I don't want to leave the place. But somebody came and called me. I'm not ready to go. I'm reluctant, right? But still, I have to go. But when I will go, in my mind, what will be there? I have to come back. Okay? So when you disturb something from their equilibrium, a stable equilibrium position, that something has tendency to again return back to the same position. ठीक है? So the same thing will happen with the dipole. Dipole को तुमने किस में रख दिया? Stable equilibrium में रखा. तो कैसे रखना होगा मुझे? In the direction of electric field. ठीक है? So there is a dipole kept like this. अब मैंने क्या किया ना, इसको डिस्टर्ब किया और इसको थोड़ा सा इधर की तरफ भेजा, स्मॉल एंगल से डिस्प्लेस किया. ठीक है? अब ऐसे जब मैंने इसको भेजा, व्हाट हैपेंड? again it has tendency to come back to this position, so again it will come back, and again I disturbed it. Again that disturbance force is there, so it will come this side again, and again it will go to the stable position, so it will keep on moving like this. ठीक है? But if you displace a dipole by very large angle, here the displacement is of very small nature, d theta, very small angle. लेकिन सपोज करो मैं जंगल में बैठी हूँ, मैं हिमाचल में बैठी हूँ और कोई मुझे वहां से दिल्ली तक भेज दिया, तो मैं बहुत दूर चली गई ना. अब मैं कैसे वापस जाऊंगी वहां? इट्स नॉट पॉसिबल, इवन इफ आई वांट, इवन इफ आई विलिंग, है ना? आई कैन नॉट गो बैक टू द जंगल थिंग अगेन instantly. I cannot easily. I will have to plan, I will have to do so many of things, right? I cannot. So in this case also, if you disturb a dipole initially at theta equal to 0 degree, if you displace it by let's say 30-degree angle, 30 degree is a big number. In this case, it won't perform SHM. Okay? So it will only perform SHM if displacement is very small, less than 10 degree. Or let's say 2-3 degree 4 degree जैसा, 10 degree से भी 10 degree भी बड़ा टर्म हो जाएगा. 7-8 degree के अराउंड, 2-3 1 2 3 4 5 लाइक दैट. ठीक है? सो देन इट विल परफॉर्म एसएचएम. अब एसएचएम परफॉर्म करेगा तो वो एसएचएम कैसा मोशन होता है? पीरियोडिक होता है. इट विल हैव टाइम पीरियड. हाउ यू विल कैलकुलेट द टाइम पीरियड? सो you just disturb the this thing, what is this, dipole, by a small angle. Let's say I'm disturbing it by an angle d theta. So मैंने इसको यहाँ से उठाकर यहाँ तक ले गई. Since this displacement is small, let's calculate the torque. Torque क्या होगा? When you have displaced it by an angle d theta, p e sin d theta, this will be the torque, right? ठीक है? And this torque will act in which direction? अगर आप ध्यान से निकालो ना इस torque को, electric field is in this sense, right? So R cross F, देख लो यहाँ पे torque, इलेक्ट्रिक फील्ड उसको किधर खींचना चाह रहा है? वापस से इधर. ठीक है? सो दिस हमने इसको डिस्प्लेस किधर किया? वी डिस्प्लेस्ड इट डी थीटा इन दिस डायरेक्शन, इन एंटी क्लॉकवाइज सेंस. टॉर्क इज एक्टिंग इन विच डायरेक्शन? क्लॉकवाइज सेंस. सो यहाँ पे लिख लो, डी थीटा का ओरिएंटेशन था एंटी क्लॉकवाइज एंड टॉर्क का ओरिएंटेशन क्या है? क्लॉकवाइज. नाउ लेट्स डू द फर्दर कैलकुलेशन. साइन थीटा का वैल्यू, थीटा होता है इफ थीटा इज स्मॉल. अगर थीटा बहुत छोटा है, लेस देन 10 डिग्री है, देन साइन थीटा को हम थीटा लिख सकते हैं. ठीक है? सो हियर डी थीटा इज अ वेरी स्मॉल एंगल, सो दिस कैन बी रिटन एज पीई डी थीटा एंड टाउ. अब देखो दोनों ये वेक्टर थिंग है, टॉर्क वेक्टर थिंग है, पीई डी थीटा, एंगल डिस्प्लेसमेंट इज अ वेक्टर थिंग. सो टाउ और डी थीटा का डायरेक्शन क्या है? ऑपोजिट है. सो डायरेक्शन वाइज इफ आई राइट, आई नीड टू गिव हियर नेगेटिव साइन. Why negative sign? Because tau and d theta are oppositely oriented. So negative sign. अब टाउ को आप क्या लिखते हो? जैसे फोर्स को आप क्या लिखते हो? मास इनटू एक्सेलरेशन. उसी तरह से टॉर्क को क्या लिखते हैं? मास विल बिकम मोमेंट ऑफ इनर्शिया, linear acceleration will become angular acceleration. So here you will write I alpha equal to minus p d theta. ठीक है? And now alpha is equal to what? Minus pe by I d theta. And you already know what is the equation of SHM. अगर तुम लोग पढ़े होगे तो पता होगा. SHM दो तरह का होता है, linear and angular. Here SHM is angular, क्योंकि एंगल के टर्म में हम बात कर रहे हैं. ठीक है? सो इन लीनियर SHM, acceleration is equal to minus omega square x, and in angular SHM, alpha is equal to minus omega square theta or d theta, whatever you have taken. So overall, alpha has to be directly proportional to minus theta. And here, if you look at carefully, alpha is directly proportional to minus d theta. So this will perform SHM if theta is a small angle. Here, this is d theta, right? So then this will become how much? PE by I will become omega square. Because this equation is same as alpha equal to minus omega square d theta. So ओमेगा स्क्वायर का वैल्यू क्या हो जाएगा? PE by I. So omega will be equal to how much? PE by I, root under. And what is time period? Time period is 2 pi by omega. So this will be this. Clear hai? Everyone understood up to this point? If not, you can let me know. किसी को डाउट है तो you can let me know now. Yes. तुम लोग पूछ सकते हो, बोल सकते हो, बता सकते हो. Everyone back to their homes. I mean, everyone is having holiday. Okay, I feel like some people are still in school, I guess. Because somewhere a holiday will be after 30th April, I guess. है ना? Tanus, okay, Lakshmi, ठीक है. चलो, thank you. चलो सब लोग समझ गए हो, तब तो कोई प्रॉब्लम ही नहीं है. सो अगर टाइम पीरियड निकालना है, यू कैन कैलकुलेट लाइक दिस. आई का वैल्यू कैसे निकालोगे? मोमेंट ऑफ इनर्शिया. अगर तुम्हारा डाइपोल इस पॉइंट के अराउंड rotate कर रहा है during SHM, then negative positive charge is here, it will have certain mass. Negative charge is here, it will have certain mass. Let's say its mass is m1, its mass is m2. This distance is a, this distance is a. Then moment of inertia is m1a square plus m2a square. Same thing you will again study in magnetism when I will be teaching you magnetic dipole. There also you will encounter time period wala thing. Here this is electric dipole, there it will be magnetic dipole, having north pole and south pole. Same equilibrium, force, torque, everything we will read. So all the formula will look same. Done it? So this will be very much helpful. Now we will learn equipotential surface. What does it mean? Equi का मतलब क्या होता है बताओ? This is equi term, right? Equi का मतलब equal. Potential, you already know. Surface, you already know. So surface having same potential everywhere, that will be called equipotential surface. Let's define equipotential surface. यहाँ पे आप ध्यान से देखो, ठीक है? So here there is a positive charge. You already know, because of positive charge Q at any distance R, what is the value of potential? What will be the value of potential here? Okay, Kiran. That is equal to KQ by R. पोटेंशियल इज व्हाट? के क्यू बाई आर. अब देखो, आर डिस्टेंस पे ऐसे ऐसे बहुत सारे पॉइंट्स होंगे ना. आर डिस्टेंस पे ऐसे ऐसे बहुत सारे पॉइंट्स होंगे. All are at r distance, and if you will join all such points, then you will get what? You will get a solid sphere or hollow sphere, right? क्योंकि चार्ज जो तुम्हारा है वो हर डायरेक्शन में ऐसे निकल रहा है. You have seen fountain you must have seen. So when water is coming out, let's say a fountain is having point source like this. So charge will go in a sphere sort of a structure. So here also, if you see carefully, what is the thing? There is, okay, just give me some second. So आप यहाँ से देख लो ध्यान से. At just give me some time. ठीक है, चलो. So now at if you join all points which are at a distance r from the charge, then you will get what? A sphere. So you are getting a sphere, and each point of this sphere is having what? Same potential, है ना? So this spherical surface is what? This will be called as equipotential surface. This will be called what? Equipotential surface. Now we need to learn more things. जैसे यहाँ से अगर आप electric field बनाओगे, it will look like this. It will look like this. So if you see carefully, electric field here is perpendicular to the equipotential surface, and it has to be perpendicular to equipotential surface. क्यों? जैसे देखो, suppose कर लो मैंने दो point लिए. Let's say this is point A and this is point B. Now let's say we have another charge, small q charge, and we want to move a small q charge from A to B. How much work we will do? Initially, small q charge is at A. We want to move it to point B. How much work we will do? So work done per unit charge is equal to potential difference. Here, work done per unit charge will be, final point is B, initial point is A, so VB minus VA. So work done is equal to how much? Q, VB minus VA. Okay? And I have told you, these all points are equipotent. All points are carrying the same potential. This is a point on equipotential surface. So potential at A is equal to potential at B, because both A and B are at same distance from the charge Q, right? So work done is becoming 0. Yani ki, if we are moving charge from A to B, we will do no work. Now, let's draw electric field like this. Suppose कर लो electric field कुछ ऐसे है, इस surface पे. I mean, I'm saying, let's say it's not perpendicular to the surface. Then this E will have a component along the surface, and this component along the surface will apply force on Q charge. Q into ES force लगेगा. And then if you are trying to move the surface along, move the charge along the surface, work will get done because electric force is acting along the surface. So if we are keeping electric field not perpendicular to the surface, we can see electric field will have a component along the surface, and this component of electric field will try to do work on the charge. But we have already seen from this thing, work done is 0. And work done will be 0 only if electric field has no component along the surface. And when electric field will have no component along the surface, if electric field line is making 90° with the surface. And that is why if you are drawing equipotential surfaces, then direction of electric field will be perpendicular to the equipotential surface. Okay? So two important things we studied. Equipotential surface का मतलब क्या? इसका क्या मतलब हुआ? बताओ. ये होगा, है ना? एंड सेकंड टर्म में हमने क्या सीखा? सेकंड पॉइंट हमने क्या सीखा बताओ? दिस इज द फर्स्ट पॉइंट. सेकंड पॉइंट हमने ये सीखा कि इलेक्ट्रिक फील्ड विल बी परपेंडिकुलर टू इक्विपोटेंशियल सरफेस. इट विल बी परपेंडिकुलर. अब जैसे देखो यहाँ पे इलेक्ट्रिक फील्ड ऐसे बनाओगे like that, it will come out like this. And this one is one equipotential surface, this is another equipotential surface, this is another. On the first, if you consider first surface, then at each point on this surface, potential is same. Then potential between, there will be difference of potential between this surface and this surface. But if you concentrate on single surface and take so many points on that surface, potential everywhere will be same. This is the concept of equipotential surface. Okay. So there is ओके, आई विल जस्ट टेक ब्रेक ऑफ 1 मिनट. ठीक है, तुम लोग तब तक फिगर आउट करो, जो भी मैंने पढ़ाया है उसको ध्यान से देखो. ठीक है, सॉरी, जस्ट गिव मी. एनीवन, एनी डाउट? किसी को डाउट है तो बताओ. Sorry, who is sending me request to record it to the cloud? It's already going live on YouTube, so you don't need to. I mean, I don't need to record it. It's there already. Okay, so please don't send it. Whoever is it. Is it someone from Avanti team? Then let me know. That is why I'm rejecting it. Sorry. ओके, एनी डाउट एनीबडी? कोई डाउट नहीं है? चलो ठीक है. सो वी विल लर्न नाउ दिस कॉन्सेप्ट, एंड दिस कॉन्सेप्ट इज ऑल्सो वेरी ब्यूटिफुल. बहुत मजा आएगा, देखना तुम लोग अच्छे से. सो नाउ व्हाट आई एम डूइंग इज, लेट्स से वी हैव अ चार्ज हियर, वी हैव अ चार्ज हियर. ठीक है, लेट्स से वी हैव अ क्यू चार्ज. लेट्स से potential of this surface is v1 and potential of this surface is v2. ठीक है, and let's say द पोटेंशियल ऑफ सरफेस, जिस जिस सरफेस का पोटेंशियल मैंने V1 लिया है, उसके रेडियस को आप R1 ले लो. एंड जिस सरफेस का V2 लिया है, उसके रेडियस को आप क्या मान लो, R2 मान लो. सो व्हाट विल बी द वैल्यू ऑफ V1? इफ यू सी हियर केयरफुली, V1 इज हाउ मच, KQ by R1. ठीक है, एंड व्हाट इज दिस V2? KQ by R2. Clearly you can see here V1 is greater than V2 क्योंकि R1 is smaller than R2, right? So V1 is greater than what? V2. Now what I'm going to tell you is, let's say distance between surface 1 and surface 2, that is this distance. Let's say this distance is very small. I want to say that R1 and R2 में ज्यादा difference नहीं है. That difference is very small. So let's say this distance is dr. dr इसलिए वो dr का मतलब होता है छोटा r. So this separation is dr, very small. Now what is my interest? My interest is that I want to move charge from first surface to second surface. How much work I need to do? So work done per unit charge क्या होता है तुम्हारा? Work done होता है what is that? Potential difference. Difference को क्या लिखोगे? V2 minus V1. So work done here is equal to how much? Q dV. This potential is also very small, V2 minus V1, since R1, R2 is very close to each other. dV is also chota, very small. इसलिए मैंने इसको dV लिखा. So work done is how much? Q dV. dV is equal to V2 minus V1. अब देखो, इसी वर्क डन को हम इलेक्ट्रिक फील्ड के टर्म में भी लिख सकते हैं. सो इलेक्ट्रिक फील्ड इज डायरेक्टेड इन दिस सेंस, व्हेन यू आर ट्राइंग टू मूव अ चार्ज फ्रॉम हियर टू हियर, इलेक्ट्रिक फील्ड विल डू वर्क because you are moving in the direction of electric field. This charge is moving in the direction of electric field. So work done can also be written in terms of force. So F dot dr you will write, and force acting on positive charge will be in the direction of electric field. So force is QE dot dr. Angle between E and dr is what? E and dr is 0 degree. So here basically it will be how much? It will be a positive work done. You can say here work done is what? Positive. डन है. एंड हियर वर्क डन जो हम हमें मिल रहा है, दोनों वर्क डन सेम होना चाहिए, है ना. हियर दिस इज द वर्क डन कैलकुलेटेड इन टर्म्स ऑफ पोटेंशियल डिफरेंस. दिस इज द वर्क डन कैलकुलेटेड बाय यूजिंग फोर्स का कॉन्सेप्ट. बट वर्क डन तो सेम होगा ना. सो बोथ आर इक्वल. नाउ लेट्स लुक एट इट. दिस वर्क डन इज F dot dr. दिस इज कमिंग पॉजिटिव. दिस इज कमिंग पॉजिटिव क्योंकि Q is positive, E is positive, dr is positive, angle between E and dr is 0 degree, so cos 0 is 1, everything positive. Here work done is what? Q is positive, Q का certain value होगा which you will take positive, right? dv is what? V2 minus V1. V2 is what? Less than V1, so this is negative, right? यानी कि ओवरऑल वर्क डन यहाँ पे क्या दिख रहा है? नेगेटिव दिख रहा है. एंड इफ यू वांट टू कंपेयर दिस टू वर्क डन, अगर इन दोनों वर्क डन को हम इक्वल करना चाहते हैं, देन वी विल हैव टू राइट क्यू डीवी इक्वल टू माइनस क्यू ई डॉट डी आर. मैंने माइनस क्यू किया, समझ में आया? क्योंकि वी आर, दोनों वर्क डन का मैग्नीट्यूड सेम है. बट इफ वी आर गोइंग टू कंपेयर दिस टू, देन to write one as an equal to another, we need to put in the negative sign. क्योंकि ये नेगेटिव है इनहेरेंटली, सो वी नीड टू मेक इट नेगेटिव ऑल्सो टू इक्वेट इट. ठीक है, सो मैंने यहाँ नेगेटिव साइन दिया. क्यू को क्यू से कट कर दो, डीवी को आप क्या लिखोगे? माइनस ई डॉट डी आर. ठीक है, सो दिस इज अ वेरी इंपॉर्टेंट रिलेशन दैट वी गेट. डीवी इक्वल टू व्हाट? माइनस ई डॉट डी आर. ठीक है, अब यहाँ से आप एक चीज और है, एक बहुत इंपॉर्टेंट रिलेशन है जिससे बहुत बार क्वेश्चन आया है, इवन इन नीट, इवन इन जेई बोथ. सो डीवी को अगर आप यहाँ पे लिखते हो ना, यू विल राइट माइनस ई डी आर कॉस थीटा. अब मुझे ये बताओ, डीवी क्या है? नेगेटिव है ना, नेगेटिव ऑफ ई डी आर कॉस थीटा. सो डीवी का वैल्यू मिनिमम कब होगा, सबसे कम कब होगा, व्हेन थीटा इज 0 डिग्री, क्योंकि व्हेन थीटा इज 0 डिग्री इट विल बी माइनस ईडीआर, एंड विच इज द मोस्ट नेगेटिव वैल्यू ऑफ माइनस ईडीआर कॉस थीटा। क्योंकि अगर आप यहां से देखो तो कॉस थीटा कैसे वैरी करता है, इट विल वेरी फ्रॉम -1 to 1, ठीक है। सो यहाँ से अगर आप देखो आई मीन कॉस थीटा का वैल्यू अगर आप लेते हो 1 लेते हो, देन दिस विल बिकम व्हाट, माइनस ईडीआर। अगर कॉस थीटा को -1 ले लिया तब तो प्लस हो जाएगा, देन डीवी विल बी मैक्सिमम ईडीआर। डन है। तो डीवी का मिनिमम वैल्यू कब मिल रहा है, व्हेन थीटा इज 0 डिग्री। इसका क्या मतलब है, इसका मतलब ये है थीटा इज एंगल बिटवीन इलेक्ट्रिक फील्ड एंड डिस्प्लेसमेंट। तो व्हेन वी मूव इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, यहां मैंने चार्ज को किसके डायरेक्शन में मूव किया था, इलेक्ट्रिक फील्ड के डायरेक्शन में मूव किया था। सो व्हेन वी मूव इन द डायरेक्शन ऑफ इलेक्ट्रिक फील्ड, दैट इज व्हेन थीटा इज इक्वल टू 0 डिग्री, डिक्रीज इन पोटेंशियल इज द मैक्सिमम, डीवी इज मैक्सिमम। इसको उल्टे सेंटेंस में पढ़ो, अगर तुमसे किसी ने ये बोला कि दिस इज द डायरेक्शन in which potential decreases the maximum, tell me the direction of electric field, so this will be the direction of electric field। क्योंकि अभी अभी हमने पढ़ा कि जब हम इलेक्ट्रिक फील्ड के डायरेक्शन में चलते हैं, then decrease in potential is what, मैक्सिमम, ठीक है। अगर मैं इलेक्ट्रिक फील्ड से कोई थीटा एंगल बनाकर चलूं, सपोज कर लो इतना एंगल बनाकर इधर जा रही हूँ, तो इधर पोटेंशियल ड्रॉप क्या हो जाएगा, सपोज कर लो थीटा 60 डिग्री है, then this will become minus EDR cos 60 minus EDR by 2. So this is more, this is greater than minus EDR, right? Done it. So what I want to tell is कि in the direction of electric field, potential decreases the maximum, or the direction in which potential decreases the maximum is the direction of electric field, vice versa, ठीक है। इसको हमेशा याद रखना। So this relation is very important, dV equal to minus E dot dr। इसके स्टेटमेंट में मैंने क्या बोला, इलेक्ट्रिक फील्ड के डायरेक्शन में पोटेंशियल मैक्सिमम डिक्रीज करता है, ठीक है। नाउ वी विल कैलकुलेट इलेक्ट्रिक पोटेंशियल ऑफ बॉडीज हैविंग कंटिन्यूअस चार्ज डिस्ट्रीब्यूशन। अब देखो यहाँ पे तुम्हें कुछ नहीं करना है, सिंपल दिस फॉर्मूला यू नीड टू कीप ऑन यूजिंग, दिस फॉर्मूला इज व्हाट, डीवी इक्वल टू माइनस ई डॉट डी आर। अब चलो कैसे होगा ये, first thing I have taken non-conducting hollow sphere. So this is a hollow sphere. It has a charge plus Q on its surface, and you have to calculate potential at this point. How you will calculate it? We already know electric field at this point. Formula हमने पढ़ा है. This charge is on the whole surface, ठीक है? ये पूरे ही surface पे होगा. So here electric field, you know, if this distance is R, then electric field is how much? KQ by R square. What will be the potential here? Use the formula. dV equal to minus E dot dr. dV equal to minus E dot dr. Let's say here this point is A. So we need to calculate potential at A. dV is change in potential. So we need to take another point. Let's say another point is infinity. ठीक है? So B point मैंने कहाँ ले लिया? Infinity. So dV will become what? Potential, initial point is infinity, final point is A. So VA minus V infinity. And this is equal to what? Let's do one thing. Yes, this will be equal to what? Minus E dot dr. या फिर एक काम करो, अभी ये वैल्यूज नहीं पुट करो, लेट्स डू वन थिंग, dv को ऐसे रख दो, माइनस ई का वैल्यू आप पुट करो, kq by r square dr. Now, if you need to calculate dv, integrate it. If you need to calculate v, integrate these things. So r will vary from where to where? Let's say r is varying from infinity to r naught, where we want to calculate potential. So at r equal to infinity, what will be the potential? 0, because at infinity we assume that electric field has no influence there, so potential will be 0. And at r naught, let's say potential is v, then this will become v minus 0, and here this will become how much? Minus kq को बाहर ले लो, dr by r square का integration क्या होगा? minus 1 by r, and this is varying from infinity to r naught. So if you put here minus kq, this will become minus 1 by r naught, minus 1 by infinity, that is 0. Okay, so this will become kq by r naught. So potential at any distance r naught because of charge on hollow sphere, non-conducting hollow sphere, will be kq by r naught. Okay, here r naught is what? It is greater than the radius of a sphere. Done it? We use this formula. Similarly, we need to calculate potential on the surface. Again, you can use the same formula and you will be getting potential on the surface is kq by r naught. So formula कुछ ऐसा आ रहा है. It seems like कि q charge is placed at the center and then we are calculating potential at r or at r naught. ठीक है. So if you are calculating potential because of non-conducting hollow sphere, then charge behaves like it is kept at the center. ठीक है. Done है. Now what if we have to calculate potential inside? So तुम लोगों ने फॉर्मूला पढ़ा है. नॉन कंडक्टिंग हॉलो स्फीयर के अंदर इलेक्ट्रिक फील्ड क्या था? 0 था. I have told you this is how much? This is 0 inside. And if it is 0, then use the formula dv equal to minus E dot dr. So here E is 0. Let's say what we are doing is we are taking 2 points inside the sphere. So I have taken A point here, B point here. Okay? So dv is your, suppose let's say Va minus Vb. So this is equal to minus E dot dr. And here E is 0. Inside point पे इलेक्ट्रिक फील्ड क्या है तुम्हारा? 0 है. इसका क्या मतलब हुआ? Va equal to Vb. So if electric field is 0 inside, it means potential at each point will be same. So for any inside point, if you pick any inside point, at every point potential is same, and that same value is equal to the potential at the surface. So potential at surface is equal to how much? Kq by r. So potential at any inside point will be also equal to how much? Kq by r. This is your formula. ठीक है. Similarly, non-conducting solid sphere. अभी तक हम क्या पढ़ रहे थे? Hollow sphere. Now this is non-conducting solid sphere. So charge is not on the surface but in the volume. ठीक है. And in this case, at distance r, if you will calculate electric field, you know here electric field is how much? Kq by r square. So it is, electric field is same as the electric field because of charge on the surface of what? Hollow sphere, right? So अगर electric field same है तो potential भी same आएगा kq by r for outside point. For inside point, for on the surface it will be how much? Kq by r. ठीक है, same as before. And for inside point, for non-conducting solid sphere having charge distributed in its volume, electric field is not zero inside. इलेक्ट्रिक फील्ड का वैल्यू तुम लोगों को याद हो कितना था? रो आर बाई 3 एप्सिलॉन नॉट फॉर एनी इनसाइड. ठीक है. सो दिस विल बी योर होमवर्क. यू हैव टू कैलकुलेट फॉर दिस थिंग. I mean, if you have to calculate what will be potential inside the non-conducting solid sphere. For any inside point, you have to calculate. Electric field formula is this. Use the basic formula dv equal to minus E dot dr. Try to calculate it. I hope you will be able to do it. Okay, many of you left, but those who are really interested are here. Thank you so much. Maybe some left because of some issues or problem. I don't know, so I should not judge. है ना? चलो किसी को डाउट है तो बताओ. दिस इज योर होमवर्क. ठीक है, बड़े अक्षर में लिखती हूँ. दिस इज योर होमवर्क. ठीक है. So you will be doing this. After this, not much is left. Only electrostatics of conductor is left. So I will be taking you through that and then we will be doing questions. ठीक है. So electrostatics में मुझे ज्यादा कुछ करना नहीं है. Just a thing of 10 or 15 minutes. After that, we will be doing. I will revise all things we have studied in electrostat through formula and then we will do question. ठीक है. So किसी को doubt है तो बताओ. I have nothing more to teach now, but if you have doubt, you can stay and ask. Yes. Thank you, Lakshmi. Thank you so much. You are from which NB, if I may know? 10th. 10th. Okay. 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 10 थैंक यू नव्यश्री, थैंक यू। आप सब किस जेएनबी से हो? इफ आई कैन नो एग्जैक्टली। ओके, चलो ठीक है। नेक्स्ट डे वी विल हैव कॉन्वर्सेशन। जेएनबी तुमकुर कोडागू। ओके, ग्रेट। चलो सही है, सही है। अपना टेक केयर करो, होमवर्क करो और क्वेश्चंस भी करते रहो इस चैप्टर से, ठीक है? कल मिलते हैं फिर से इसी समय। एंड टिल देन एवरीवन टेक केयर ऑफ योरसेल्फ। बाय एवरीवन, बाय नव्यश्री, बाय एवरीवन, बाय बाय।